Welcome to our podcast. In this episode, we are going to discuss about the future. It is about something really small, but with great implications about us, the humankind, and our planet. Hydrogen. Hydrogen has often been called the fuel of the future. But here's the thing. It's starting to look more like the fuel of the present. It's light, powerful, and incredibly versatile. You can use hydrogen to power vehicles, generate electricity, and even store excess renewable energy from solar and wind. But making all that work efficiently and safely? That's where the hydrogen system designer comes in. Today, Chris will help us dive in this rather unknown industry that emerges, a new profession, and professionals that come along with it. Chris, welcome to our podcast.
Thank you, Bill. Nice to be here with you. The hydrogen system designers are the people who create and optimize the entire infrastructure that makes hydrogen possible, from electrolyzers that split water into hydrogen and oxygen, to storage tanks, pipelines, fuel cells, and control systems that keep everything running smoothly. Think of them as architects of the hydrogen ecosystem, blending engineering, chemistry, and environmental science to make energy cleaner, safer, and smarter.
Now, what does it actually take to become one of these designers?
Well, first, a solid foundation in engineering principles, thermodynamics, fluid mechanics, and materials science. Hydrogen behaves differently from other gases. It's the smallest molecule in the universe, which makes it tricky to contain and store. Then comes renewable integration, since most green hydrogen is made with electricity from solar or wind. Designers need to balance electrical systems, efficiency, and safety standards. And speaking of safety, that's huge. Hydrogen is flammable, so system designers must ensure redundant safety mechanisms, proper ventilation, and pressure management at every stage.
So, these are a lot of systems thinking.
Hydrogen design isn't about a single machine. It's about creating a network that connects production, storage, transport, and use, all in one coherent, optimized system. Many of today's professionals come from chemical engineering, mechanical engineering, or energy systems backgrounds, and increasingly, new programs in hydrogen technology are emerging worldwide.
So, what does a day in the life of a hydrogen system designer look like?
Imagine this. It's Monday morning. You're running simulation software, testing how hydrogen production efficiency changes under different weather conditions. By Tuesday, you're reviewing designs with safety engineers, making sure everything meets national codes and standards. Midweek, you're meeting with city planners and clients, discussing the feasibility of a new hydrogen fueling corridor for trucks. And by Friday, you're out in the field, inspecting the installation of an electrolyzer system, making sure it performs exactly as designed. It's a job that mixes digital modeling, hands-on engineering, and environmental problem-solving. Every project feels like a glimpse into the future.
Of course. But designing for the future surely doesn't come without challenges.
Correct. First, there's the cost. Right now, producing green hydrogen, the clean kind made with renewable electricity, is still more expensive than traditional fuels. Second,
Hold on, Chris. Please allow me to interrupt you right there. You mentioned the clean kind? I thought hydrogen is always clean. Isn't that the case?
well, no, at least today it isn't. There are basically three kinds, or colors as we say, of hydrogen depending on the production source. There is green hydrogen, which is generated from renewable energy sources via water electrolysis and zero carbon dioxide emissions during the manufacturing process. This is considered the holy grail of the hydrogen economy. Then there is the blue hydrogen, which is generated from natural gas, which is methane, through carbon capture and storage technology. It results in lower carbon dioxide emissions, though it does not eliminate them entirely. And finally, we have the gray hydrogen, which is generated from fossil fuels without carbon dioxide capture, resulting, as you understand, in significant emissions. Our target is to transition to solely green hydrogen production, but we are not there yet.
It is clear now, and it's worth mentioning the mindset in measuring everything in the amount of emissions. But let's get back to the challenges. You mentioned the high cost of producing green hydrogen.
Yes, it is still more expensive to produce than traditional fuel. Then there is the infrastructure. We don't yet have a global network of hydrogen pipelines or refueling stations. And third, public perception. Hydrogen is safe when handled correctly, but memories of early experiments still make some people wary. This is where hydrogen system designers really earn their reputation. They work to make systems more efficient, affordable, and reliable, so hydrogen can move from niche applications to mainstream use. To put it briefly, they help with their innovations close the gap between what's possible and what's practical.
Zooming out for a moment, the hydrogen revolution is global. Countries like Japan, Germany, South Korea, and the United States are investing billions in hydrogen projects. Is Europe falling behind?
Europe is developing the hydrogen backbone, a massive network of pipelines connecting renewable production sites across the continent. And this momentum means one thing: hydrogen system designers are in demand. By 2050, the hydrogen economy could create millions of jobs. And system designers will be at the center of it all, shaping how nations generate and distribute clean energy. It's a career that blends technology, sustainability, and global impact, a chance to literally design the transition to net zero.
But let's not forget, behind every system, there's a human story. What can you tell us about the human factor blending in this complex system?
Hydrogen system designers aren't just building machines. They're building hope for a cleaner future. Their work reduces emissions, powers clean transport, and supports sustainable industries. You know, I once spoke to a designer working on a hydrogen-powered ferry in Norway. She said, "Every time that ferry leaves the dock, without emitting a single puff of smoke, I feel proud. It's like watching the future in motion." Moments like that remind us, this isn't just engineering.
Yes, the everyday life repercussions are significant, and they will get bigger.
This is the motive. It's more of purpose-driven innovation than anything else.
So, what is the background of a hydrogen system designer in terms of education?
Start with a degree in engineering, physics, or environmental science. Then specialize in energy systems, hydrogen technologies, or process modeling. Get hands-on experience through internships in renewable energy or industrial design projects. And most importantly, stay curious. This field is evolving fast, and lifelong learning is part of the job description.
Thank you very much, Chris, for shedding light in this new tech and its professionals. It's been a pleasure. Ladies and gentlemen, hydrogen may be the smallest molecule in the universe, but it holds enormous potential. And the people designing its systems, the hydrogen system designers, are quietly building the backbone of a cleaner, more sustainable world. So next time you hear about a hydrogen bus, a zero-emission factory, or a renewable energy hub, remember the innovators behind the scenes, designing the flow of the future. Thank you all for listening.